Thanks. Yeah, I think why we need mouthful guidance is because the experience is a handful when you want to, talk about different L2s. And one of the things that we are trying to do at Avail is we are trying to unify the experience and the overall infrastructure that is at play on the various rollups. And I would just like to, go through a little bit on how we are trying to do it, what are the essential ingredients of it, and what is the end objective. Right. So
At Avail, we are building three things. We are building the Avail DA, which is the essential base layer. That's the data availability solution that we have been building for the last 3 years almost. And it's going to the mainnet very soon. But apart from that, we were thinking that, yes, rollups are proliferating the market. There will be hundreds of rollups. I think last talk also talked about all the different rollups that are going to be in the market and how the access is completely broken and things like that. And hence, we were thinking by solving the data availability problem, which is what the rollups are hungry for, what's next? The next thing is about the fragmentation that is happening across the L2s, and that's why we have been building on Avail Nexus. I will go into the Nexus bit throughout the talk, but I want to also touch upon the Fusion. Now, Fusion is about adding cryptoeconomic guarantees back to the base layer so that you can have a secure base layer on which all the infrastructures on top can interplay. Right. So why is Avail DA special, right? What we want to do is we want to have easy verifiability. One of the core reasons why, hopefully we are all in blockchain space, is that we want end user verifiability across all the applications that we are building in this space. And how we are trying to enable it is through KZG commitments and data availability sampling. So what that means is every user would be able to verify within their client, within their wallets, whether the data behind the rollup that they're interacting with is actually available or not. I think the scroll is a little bit broken, so I would manually scroll this. At Avail Nexus, we are now trying to do what we call as proof aggregation and sequence adoption. What does it mean? We want to have a single point of aggregation for proofs within all the rollups. And with sequences selection, we want to provide a way for different rollup sequencers to come in and bid for them to be able to produce blocks. The sequences selection bit is what we are not focusing right now. We are more focusing on the proof aggregation. Now, why this is important is only when you have a common DA layer, you can verify execution on top, and the interoperability constructs work. The moment you go across DA layers, your verifiability and the security assumptions completely change based on the foreign chain that you're interacting with. Okay. And in Avail Fusion, we were thinking of, yes, we have the Avail token, which is there for staking, but can we have additive economic guarantees baked into the consensus of the chain? And that's why we are thinking of how we can include Bitcoin, Ethereum, Solana, and plenty of rollup tokens which are trying to find their place in the market about utility, how we can add them to the base layer in order for them to contribute to the consensus of the chain which is securing them. Right. So with Avail Nexus, we are trying to do what we call as trust minimized rollup interoperability. And I think the trust minimization factor is important. Why trust minimization is important is because think of the interaction that you do today in the typical Web 2. What you do is you go to a marketplace, you go to Amazon. The Amazon team doesn't exactly know which bank you're interacting with. So what happens is they use a payment aggregator in the middle. So at Amazon, you click the checkout, it goes to someone like PayPal, Stripe, Builders, whatever. At that point, you give your payment information. And depending on which kind of card are you talking about, it goes to someone like a Visa or a MasterCard or an Amex. even then they do not process it directly. They actually send it to the bank confirms it, that confirmation goes back to PayPal confirms it back to Amazon, and then it is done. Only then your payment is done. And we want to have the same spirit in terms of Web3 applications, because we think that this kind of an architecture is very elegant. This is a very much microservices based architecture where each of these components can scale onto demand. If there is a sale going on, if it's a Black Friday or whatever, Amazon can independently scale up. And if there are, I am a XYZ payment provider and I don't have enough users, I can still have low scale of my product. And this is what is missing today. And this is why we are building just another L2, like the previous person said, right? The other L2 is not about solving a problem. It's about being sovereign in the sense of what kind of scalability you need, what kind of latency do you need, what kind of interoperability do you need. It's about that. And that is why we think of a world where applications are not on monolithic chains, but are on rollups. At the same time, we fundamentally agree that the experience is broken, and that is why we are talking about it. And this is how a Web3 cross-chain bridging works. On Ethereum, you have to lock your asset. On, let's say, a Cosmos or any other L1, you have to mint asset based on the guarantee that this locking has been done. So on Cosmos, you verify that the locking is there. On the other hand, when you burn your assets, you show a proof of burn and then do an unlock. Of course, there are many other ways to do bridging. This is a typical lock and mint mechanism. There are things that are out there which are very different. I was talking to some booth upstairs, and they were talking about how they are doing all of this in a single click and so on and so forth. All of that is great, but think of the complexity that it takes to verify one chain on the other. For example, the fact that you have locked your tokens here, what is the guarantee of that you can provide here? The only guarantee, the best-in-class guarantee, which many fail to provide even today, the best-in-class guarantee that you can provide is light client verifiability, which means that you can verify that Ethereum consensus has agreed to the fact that this has been locked. To be very honest, you don't even do that. Most bridges, even light client bridges, rely on sync committee and not the overall consensus, but let's not go there. And this is how cross-chain interop among various chains roughly works. You have multitude of these chains, they have their own users, and depending on from which chain to which chain you want to interact, there are plethora of ways. There are, of course, aggregators on top. People like Socket and others are doing fantastic job of abstracting away all of this complexity. But that doesn't change the fundamental fact about how the interaction is happening behind. And as you can see, this is the real problem, right? This is the real problem when I talk about another L2, is that people are seeing this kind of a mess and they don't want another vertex here. They don't want to have additional complexity just because I went there and figured that I want a new L2. That's the complexity that we are facing right now, and this is what we are trying to fundamentally change. What we are trying to do is, we are trying to provide what we call as Avail Nexus. Let's talk about 3-4 different L2s. Let's say a ZK Sync Era, a Polygon ZK AVM, a Starkware Starknet, and a plethora of other L2s like Scroll, Linea, and others. They all want to talk to each other. What we want to do is, we want to have a nexus in the middle where you can have light client verifiability of all of these chains within Nexus. And this is only possible when you have the fundamentally talk about rollups on top. Because if you think about it, then the rollup verifiability comes from two facts. The rollup verifiability comes from the fact that you have verified execution and you have verified data availability. Any one of them missing is actually fundamentally invalid. It is actually insecure. If you do not verify the execution of the other chain, if Starknet doesn't verify the execution of ZK Sync Era, it cannot migrate assets in a trust minimized manner. Similarly, if ZK AVM doesn't know what state transition function is crawl doing, it cannot do this interaction. And that is why we are trying to provide Nexus as a coordination layer where it acts as the middleware which connects all of these chains, and all of these are light client verifiable from within the Nexus. I will talk a little bit about how that happens, but before I go there, this is the kind of interaction that we want. We want to have contingent transactions of one chain on the other. Think of it like if you want to have an OpenSea NFT, what you can do is you can have a contingent transaction where a NFT is actually put on a hold state unless the payment is actually processed on Polygon, for example. And this is very, very normal in the Web2 world, right? If you go and try to buy an aeroplane ticket, it's not that your seat is booked immediately without processing the payment. And it's also not that your seat is actually sold to someone else while you're processing your payment. It's put on a hold state. It's the same when you want to buy tickets on a stadium, a plane booking, anything on a marketplace. That is the typical way of how marketplaces work. And this is exactly what we want to enable, but in a trust minimized manner. If there is no trust minimization here, then we are not improving the status quo. We are not here to build, Web2 products with the same guarantees on a new wrapper. We are here to build fundamentally better products which can give better security guarantees to the end user. Now comes the complicated part about how exactly. How exactly we want to do it is we want to have a very thin Nexus runtime. What the Nexus runtime does is it checks for continuity among the various participating rollups. But typically how it is done is that each of these rollup proofs are actually taken and converted into an adapter. And why this is important is because if you think about the complexity of unificating all of these chains, there is fundamental complexity involved in being able to roll all this up into an aggregated proof. For example, ZK Sync uses a modified Plonk, whereas Polygon ZK EVM uses a F-Flonk, Scroll uses a Groth16, Linea uses optimistic plus ZK proofs, and so it's a wild world out there, even if you talk about all being ZK provable. So that's why we want to create this adapter where the adapter takes heterogeneous proof systems together to create a homogeneous proof on top. And on this homogeneous proof is where you can do aggregation, because homogeneous aggregations are much faster and they have coherent security guarantees on top. And then the Nexus runtime is just a coordination engine which just checks that, for example, all these proofs are not only sound but also complete. And this is what the world we want to take a look at. It's where conditional execution is empowered, right? How it is being done is that for the user, all of this will be abstracted, as many of you would certainly understand. The marketplace basically provides the NFT chain with some payment details and an ability to hold the NFT for some time. The time duration is specified, and how you verify it is not by timeout, but by showing either inclusion proof or proof of non-inclusion. And this is one of the biggest guarantees that you can provide. In any other system, it's very hard to provide proofs of non-inclusion. Non-inclusion proofs are notoriously hard, unless you build the data structures from the ground up in which you can control. And that's what we are trying to do on the Nexus middleware. We want to not only provide this guarantee to the NFT chain that the payment has been processed, but we also want to give an inclusion proof through the marketplace. And what that means is we can now verify both execution and data availability on the Nexus adapter. And how is that possible is that from all of the ZK Sync, ERA, ZK EVM, other L2s, you take the proof, but this proof only does state validity, which means that the state updates were done correctly. That's the only thing that you prove by these proofs. You take it to the adapter, you create an aggregate proof. This is great, and it can be verified by any light client, which means that I, as a user, I can verify all these chains by verifying a single proof. And this single proof takes 60 milliseconds if it's a Groth16 in typical hardware that's in your mobile phones. That is what you're enabling by providing an aggregate proof over all the execution. But as I said, this is not enough. This is not enough because if I change the ordering of the transactions, your execution proofs do not hold true. For example, if I give you 5 numbers and you have to do an exponentiation for one over the other to the next, and if I change the ordering, then your actual outcome is going to change. And that is why it is important to have the data available for safety or liveness guarantees, depending on what kind of rollups are you talking about, but also because your ordering guarantees should come from the DA layer. And that's why for Avail DA, from day one, we have been focusing on building a light client which provides ultimate DA guarantees using data availability sampling. You do not need to download the entire blocks. You can just sample parts of the block and be very sure that the entire data and the ordering is available. And this is together, both of this gives you the ability to verify in a light client. I think Vitalik has also been talking about light client verifiability of Ethereum and such. And these are important because unless you have light client verifiability, not only on the execution, but about the data availability, fundamentally you do not get guarantees. You can have crypto economic guarantees, but cryptographic guarantees are not possible. And hence, this is the world that we are trying to look at. We are trying to look at a world where there are n number of modular chains. I don't care if you go from n to n plus 1 and build just another rollup that you want to do, but we want to provide a unified interface which is powered by light clients, which can improve not only the user experience, but also the developer experience on this modular world. And yeah, so I will kind of end by saying that we want to accelerate the unification of Web3 by providing ways to interoperate in a trust-minimized manner. Happy to answer questions and connect later if you want. Thank you.
I'm curious, how much data, what's sort of the throughput in terms of how much data could be put in there, and what is the latency of the confirmations?
So right now, the data size is 2 MB per block, which is erasure coded to 4. But this is a scalable layer, which means that we have tried up to 128 MB and beyond. But the point is that you just cannot provide a huge block with no demand. The economics doesn't work that way. For example, if you are a validator of our chain, you wouldn't want to provide the infrastructure to support 128 MB blocks or 2 GB blocks or whatever, unless there is a real demand which is subsidizing your cost. And that's why we have been testing higher numbers, but right now we have been stopping it to a 2 MB because we think that the market is still not ready for a 2 MB block. And now coming to the latency for our chain is we produce a block every 20 seconds, but our finality is every 2 blocks under the assumption that there is no network partition. If the network partitions, then it will take some more time unless the partition is resolved, and then you can finalize. And that's typical for every chain, right? So we have a hybrid ledger, which means that if there is delayed finality, which means that there is a problem with the validators not being able to reach consensus on the finality, but the chain goes on because it has liveness for them.
So every 40 seconds, basically, and then 2 megabytes currently.
Roughly, yes.
Yeah.
And just to compare that with other chains, for example, on Ethereum, if you post 4844 blobs, it takes you roughly 15 minutes to get finality. On Celestia, if you post data blobs, then although you reach instant finality on the block because they use a Tendermint chain, but because there is a fraud proof, it can take from minutes to days, depending on whom in Celestia you ask.
Maybe one more question. Do you see the primary sort of users of this being rollups?
Yeah, absolutely. The users of us are rollups. Right? Even today, we have been talking to tens of rollups. All the rollup stacks have running integrations with us, so you can today On the ETH Global Hackathon, you can go and try out our Arbitrum Orbit, OP Stack, Polygon CDK, ZK Sync Hyperchain, Starkware Madara, any kind of integration you can run. You can even use something like a stacker, something like a sovereign SDK, something like Rollkit to power your own rollup using Avail.
Okay, two more questions. So first of all, well, maybe, but so for 2 megabytes every 20 seconds doesn't sound very much. Like, how much data would rollups or transaction volume would rollups be able to sort of handle to like fit into that?
So, very good question. Like, just to give comparisons, because that's the most that we can do is like give comparison with the status quo. Ethereum blob has a capacity of 370 KB in average, and it can go up to a 720 or something KB at the maximum using EIP 1559. But on an average, it has, for every 12 seconds, it has a 300 KB, and there is no congestion. Even with Arbitrum, OP-Stack, Linea, Tyco, Starkware, all of them using blobs, there is no congestion today, and that's why it's dirt cheap to post blob transactions on Ethereum. And that is the lack of the demand that we are talking about. So 2 MB per 20 second is low, I agree, but the demand is also low. And that's why I said that when the demand hits, we have a scalable architecture, but unless the demand is there is no point in tuning up and creating empty blocks.
Do you see other applications besides rollups that would need to use DA?
Yeah, absolutely. Like any kind of verifiable computation that you want to do, and rollups are just a construct, right? Rollup is a construct because it's a construct which takes execution off-chain and puts assertions on-chain. And that can be done for many, many different types of application. It doesn't have to be branded as a rollup. Even within rollups, there are different types of rollups, and there is definitions of what you want to call a rollup and such. But any kind of verifiable computation, off-chain verifiable computation, needs data availability.
Cool, thank you.
Hi. In terms of rollups posting data to Avail, I was just curious to know if you guys were prioritizing, or if you prioritize any particular like rollup framework, or is there something that you in particular are excited about, like OP Stack or Arbitrum Nitro or something like that?
I mean, all of them are great, I have to say that. To be credibly neutral, I cannot stand on stage and prioritize one. But at the same time, I think each one of them have a different focus, and that is great for us. I will give you some examples. On Arbitrum Orbit, we have Stylus. And Stylus gives you the ability to provide WASM executions, right? Which is awesome. Think of the smart contracts that you can build and the Rust code that you can run, and them being talking to each other. On the other side, in the OP stack, we have seen the gas getting tuned up. We have seen huge amounts of transaction getting hit on the base, and it is being sustaining. And they are trying to push the limits on gigagas per second that you can process and such. So their optimizations helps us in that way. On the other hand, ZK Sync is trying to reduce the prover cost. It is trying to show that on a laptop you can provide a proof, which is very different than a Starkware Madara. A Madara is trying to push for sovereign chains. They are not settled rollups, they are sovereign rollups, and hence their optimizations are looking very, very different. They are not talking about the smart contract in which you can settle, they are talking about end user verifiable proofs, which may be settled on Ethereum and also on Bitcoin, for example. They have been talking about that. So all these stacks are prioritizing different parts, and we are happy to collaborate with each one of them. And then there are other stacks. For example, a stacker is providing micro rollup, which you can customize your own execution and state and such. In Sovereign SDK, you are providing extremely good guarantees on a based rollup, guarantees which are never seen before in any other stack. There is a Tyco, there is a Scroll. I mean, each one of them are different.
And just to follow up, while you guys go on mainnet, are there already any particular users that you can already talk about, or like somebody? I don't know if that's a bit
I mean, this is about predicting future, which I would.
Like, do you guys already have certain users in the
Yes.
pipeline for mainnet?
Yes.
And is there somebody that you can already talk about?
Yes, so there is a post. I would love to refer you to the post where we have talked about all our partners and also their stages of development. One of the problems that we see is I can tell you like, yes, we have 40 partnerships, and then you will say like, okay, but how many of them are going to use on day one of mainnet? And that is a tricky question to ask because every day the stack is changing. None of these stacks are ready for mainstream on an alternate DA. The interfaces we are collectively building with Arbitrum, with OP, with Polygon, with ZK Sync, we are collectively building the interfaces. But even with that, the stable source code is not there. There are forks that we have to maintain and such, which means that whenever you're talking about mainnet, we have to be extremely, extremely careful about the security. The audits have to be complete. They have to be stable. They have to be tested on testnet. Some testnets are going on. I mean, for example, on OP testnet we are hosting for the ETH Global Hackathon for us to be stress test whether that is complete or not. So.
Cool, thank you.